we've always done for the derivatives that I've given you is e to the x is e to the x, right? We talked about that one. And then the other one were all power rules. Like it's a variable base to a numerical exponent. Please make sure your assignments are away. All right. So today what we're going to talk about is product rule when you have two things multiplied together. So do you see these two things are multiplied together here? We can't just go and do power rule with them. We have two things multiplied. So when you have two things multiplied, to get f prime of x, you take f and g, and then you do f prime of g, or f times g prime, and then g times f prime, which seems complicated. Now, I just want to show you something here. I am going to actually rearrange those. So every single time I do product rule, I'm going to do g f prime of x plus f g prime of x. And the reason why I do that is because that is the top of quotient rule. Quotient rule, you have to start with g first, your regular g. So do you see how they're starting with a regular f, and then here they're starting with regular g? With addition, can we not flip-flop those? Yes. So I will always go g f prime plus f g prime. And how I write it lazily, so I go like this, g, or I go f g prime equals gf prime plus fg prime. Doesn't matter how you write the formula because you're not given one. So they get what they get and they don't get upset. So it looks way more complex than it is. It's not really that bad, I promise you. So you get y, they want us to differentiate the product of the two functions. Find y prime, so the first derivative is the tangent slope, correct? That hasn't changed at all. Of y equals f times g. Could I rearrange those and make the other one f and the other one g? Yeah, it's multiplication, correct? It doesn't make a difference. It also doesn't make a difference which one you make f and g, so I wouldn't waste my time changing them around. All right. So y equals, well, in order to find our y equals 1 plus x squared e to the x. I always rewrite my question, and I get f, and I get g. Y prime equals, now we're going to need f, g, f prime, and g prime, right? That's what the formula has in it. So let's find f and g prime first. So f prime is what? 1 plus x squared. What's the derivative of 1? 0. It goes away. And then x squared is 2x. And then what's the derivative of e to the x? E to the x. So we're going to get g, which is e to the x, f prime, which is 2x, plus f, which is 1 plus x squared, times g prime, which is e to the x. So this is g f prime plus f g prime. Technically, is what we did, right? We just filled it into the formula. G f prime plus f g prime. Okay? Looking at me. Whenever you have a numerical base to a variable exponent, like e to the x, right? Numerical base to a variable exponent, like e to the x, we said that the derivative, so if y was e to the x, I said that y prime, when you get a numerical base to a variable exponent, the first thing you do is rewrite it, then you ln the base, and then you do the derivative of the exponent, which was 1, correct? Ln e we discussed. What is ln e the same as? 1, because it'd be log e to the e, right? Which is 1. So this becomes a 1, that becomes a 1. So y prime equals e to the x, correct? But the key thing, whenever you have a numerical base to a variable exponent, the first step of that is to rewrite it. We agree? So whenever you have one of those involved in your product rule, you'll be able to GCF it out because it's going to be in g and it's going to be in g prime, correct? So if we look here, here's my one term. Here's my second term, which you always get two terms in the product rule. What do both of them have in common? an e to the x. So if ever an e to the x is involved in product rule, your second step is going to be to take that e to the x out, because it's going to be in both. It's in its normal and in its derivative, so we'll always be in both terms. So when we GCF the e to the x out, e to the x 2x, you're left with a 2x. Plus taking e to the x out, we're left with 1 plus x squared. Can I collect any like terms here? Do I have to make it in descending powers of x? Do you know how many of you sit here and are like stuck or don't go one more step? So we're going to write ourselves a little side note with maybe a highlighter to remind ourselves. Whenever we have, see this little baby? Numerical base to a variable exponent, you will GCF in power rule. Power rule? Product rule. Making up things. Write this down. Less talking, more writing. Why would I highlight this? Why would I write it down? Why would I tell you to put red around it? Because no one does it. And then they call me over and they're like, this is what my answer doesn't match any other. And I'm like, yeah, because you're listening. Put red around it. Remember it. If you remember this step, questions with numerical bases to variable exponents are really easy, because they're often done after you take the GCF out. Or worst case scenario, you have to like collect the like term or something. Like it's way easier than anything else. It's way easier than example 2. Let's look at example 2. So you're boxing these. So we're differentiating the product in 2 ways. So I'm going to show you the 2 ways. The first way is both of these are variable bases to numerical exponents, correct? This is a variable base numerical exponent. Variable base numerical exponent. 1 is still a variable base to a numerical exponent because it's a v to the 0, technically, right? So if they are like that, if they're a variable base to a numerical exponent, you could distribute and do product rule. Distribute and do power rule. Why do they label them both with P's? Because my brain is not comprehending both. So you could expand them and do power rule, or we're going to do product rule as example 2. So the first way we can do this is expand it. So we have f of v. Now people are like, well, this is stuff I don't like v's. I want it to be x's. Deal. All right. 5v, and just be appreciative it's not a t that looks like a plus sign. Okay? We're going to take what we get. It's just a v. You will be okay. It literally stresses you guys out. I know it does. I've watched it in faces before, and I'm sure it's not going to be any difference. It's just a v. It's just a v. It's not an x. It's a v. All right. So I'm going to expand it. Now, guys, if I expand it and then collect like terms, have I done the derivative or anything yet? No. So I still have f of v. Some people will go f prime of v and expand it. I'm like, you haven't done a derivative at all, right? You've just expanded it. So we're going to get 5v to the what? v5. And then 5v squared minus 1 is minus 5v squared. Minus v times v cubed is minus v to the 4. And then minus v times negative 1 is positive v. And then 1 times v cubed is v cubed. 1 times negative 1 is negative 1. So f of v equals 5v to the 5 minus v squared plus v minus 1. What did I screw up?
You put v to the power 3 when it's supposed to be v to the power 4.
Where?
It's v times v to the power
This one and this one?
Yeah.
Is this one?
Yeah.
Oh, that's going to ruin it. Ah, aggressive erasing. Oh wait, minus v4 plus v cubed minus 5v squared. Did you say Jeter? I hope that's what you said. It's okay. F prime of v equals 25v4 minus 4v cubed plus 3v squared minus 10v minus 1. So that's one way you could do it. And we can only do this because it's a polynomial times a polynomial. When you have an e to the x in there or something like that, it's you can expand it, but then you're still going to have a product rule embedded. Like if I did that up here, guys, I would end up with 1 e to the x, great. And then I would end up with e to the x times x squared, which is a product rule. So that wouldn't have been any faster. Yeah. No. Negative.
You've got minus b.
I don't know. This? It's supposed to be plus? That's what you're saying to me? I thought you meant this one. I was like, no, that's 1 times negative 1. All right, 2. So we have F, we have G. Just so you know, I'll never do those as a power rule. I'll always just do product because it's actually not that bad. So F prime is what? What is F prime? 10b minus 1. Guys? G prime? 3b squared. So F prime of v is going to be G, which is v cubed minus 1, times F prime, which is 10v minus 1, times, or plus F, 5v squared minus v plus 1, times G prime, which is 3v squared. Oh, my contacts today, I'm really regretting it. My glasses and contacts are not very prescription. So we're in a little bit of problematic. We're not right. I'm there. It's okay. Okay, what do we have left? Can we take out a GCF or anything on this one? No. When it's just a plain old power rule that got you, like our F prime is a power rule, our G prime is a power rule. Do you see that? When they are power rules, the only thing you can do is expand and collect like terms. You can't take out GCFs. If one of these is going to be a chain rule, which will happen this week, then we'll be able to take out a GCF. So chain rules, you can take out GCFs. Numerical basis to variable exponents, you can take out GCFs. But if your F prime and G prime are straight up power rules, to get them, you're just going to have to expand and collect like terms. So we're going to get 10b to the 4 minus v cubed. Correct me if I mess up. My eyesight not great. Do not freeze on me. Minus 10b. Guys, you gotta stop talking. Plus 1 plus 15b to the 4 minus 4b cubed plus 3b squared. I said 15b to the 4 and then wrote 3. Great day. All right. So 10 and 15 is 25b to the 4. And then negative b cubed. Where? This? Oh, I think I took the 4 that I was saying here and wrote it there like a stunner. Guys, you have to stop talking because you're sidetracking my poor brain.
I'm sorry.
Yeah, it's totally. It's not keep on the table. Negative 4b cubed minus 3b cubed negative 4b cubed plus 3b squared minus 10b plus 1.
The 25
B to the 4th, yeah. This one I can't write as just a basic tower rule because it has a binomial denominator. Do you see that? Can we write every term? If every term has a monomial denominator, can I just write each one over it? So for example, if I had y equals x squared plus 3x minus 6 all over x, do I have to do quotient rule with that when I have a monomial denominator? No, you guys will all do quotient rule, but you don't have to. What could you do? Yeah, so you could go x squared over x plus 3x over x minus 6 over x. And then you'd rewrite this as x plus 3 minus 6 x to the negative 1, and we could do power rule. Correct? This one, however, has a what denominator? A binomial. You have to do quotient rule. You don't get a choice. Okay? And this is a nice quotient rule because the derivative of 1 is 0, so half of your quotient rule is going to go bye-bye. Right? The problem with quotient rule that I find that I make the mistakes in is I forget the g squared on the bottom. Because you do your top, you do g, f prime minus f, g prime, and then just kind of forget the g squared. You're like, I've done enough. So it won't work out for you if you keep forgetting the g squared, right? So this is f, this is g. We don't get a choice. D over dx is just saying I want the derivative of that, of what's beside it. Now, people don't know how to write it out. They're like, I want to put y prime. You can't write y prime. This is saying find the derivative of this. So I have to write d over dx, find the derivative of 1 over x squared plus x, and then say that that equals, and then start doing my quotient rule. Okay? This is like the derivative of this equals. That's what you're showing. You can't say y prime. There's not even a y to be found in this question. Right? If it was a y question, it would be y equals 1 over x squared plus x. Y equals 1 over x squared plus x, and then you could go y prime, correct? This is a totally different notation. You can't just be like, I don't like that notation. I'm going to do it differently. You don't get that choice. And some profs only do this notation. So, depends on who you get. We're going to practice both. All right. So, we are going to go g, which is x squared plus x. Now we want to have f prime up here. What's f prime? 0. What's g prime? 2x plus 1. So we're going to get g times f prime minus f times g prime. I don't know why I put in brackets, but sure. Now this is gone, correct? Yeah? And then over g squared, x squared plus x squared. Now they're saying if your numerator is a 1, then you could technically go 1 or negative the derivative of f over fx squared. You could technically do that. It's another thing to memorize. I would just do quotient rule. I'm just showing that as something you could remember. But I would just do quotient rule and it cancels off and I don't have to remember another formula. But that's just me. Okay? But whenever you have 1 over something, you'll be able to use that formula. So then we're left with negative 2x minus 1 over x squared plus x squared. Now, a lot of people want to tell me, oh, I'm just going to take an x out of that. You can't. It's squared, right? And some people FOIL it out. Don't. You just made it worse. Just, that's it. Because next unit, we're going to have to set this equal to 0 and get the critical numbers of this. So we'll take the x squared plus x to the 2, set it equal to 0, and the negative 2x minus 1, set it equal to 0, correct? So if you expand this out, you're going to have to factor it back. So there's no point in doing that. So when you get your g squared, Leave it as g squared, which is nicer than having to expand it. So that's a gift, right? Don't make it work harder. All right. This one follows the same rule because e to the negative x is actually the same as d over dx 1 over e to the x, technically. I'm going to show you another way that you can do this as well. So e to the negative x is not, the derivative to that is not e to the negative x. It only works as e to the x because the ln x canceled off and it was multiplied by 1, correct? But I'm going to show you how you can do this one in quotient rule. And then I'll show you how you can do it in the other rule we use. So this is f, this is g, f prime is 0, g prime is e to the x. So we get d over dx, e to the negative x. So we get g, which is e to the x, times f prime, which is 0, so that's gone, minus f, which is 1, times g prime, which is e to the x, all over e to the x squared. So we get negative e to the x over e to the x squared. This cancels off one of these, and I'm left with negative 1 over e to the x, which equals negative e to the negative x, which is a long, convoluted process to get to that answer. What I told you is whenever you're given just a numerical base to a variable exponent, you just follow the same chain rule. I was teaching it ahead of time. So if I have d over d to the dx of e to the negative x, this is a numerical base. E is a number, right? 2.7181, blah, 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 blah. Okay? To a variable exponent, what did I tell you you have to do? You first rewrite it, so e to the negative x, and you get ln of the base, so ln of e, and then what do you multiply by? You wrote it on a previous page. Rewrite it, ln of the base, derivative of the power. So negative 1. Ln of e is just 1, correct? So my answer is negative e to the negative x. Done. So you rewrite it, ln the base, derivative of the exponent, every time. If you have a numerical base to a variable exponent. It's a lot less complicated. Okay, next page. So we're going to use the power rule on these ones. We've already went over this. We can use the power rule because we can move these up, right? So this one, I would say d over dx, x to the negative 1. How do I do the derivative of that? It's a variable-based numerical exponent, so I can use power rule, correct? So I take the number, I drop it in front. So negative 1, x to the what? Negative 2. This is literally a repeat of what we've done already. So they can leave it like that. Or the negative 2 is only on the x. Do you see that? If it was on the negative 1, it would be in brackets, correct? Which it's not. So the negative 1 stays in the numerator, and the x squared drops to the denominator to become positive. So I get a ton of people doing this wrong because they take the negative 1 and drop to the bottom 2. So the negative 2 is only on the x. Yeah? Okay, how can I do power rule with b? Could I do quotient rule? Yes, but I want to. You bring the u2 up. What does it become? U to the negative 2. So f prime of u equals what? Take the negative 2, drop it in front. U to the what? negative 3. Which we can leave it like that, or we can rewrite it, and we need to know both because it depends on how they write it, right? So that negative 3 is on the u, yes? That negative 3 is not on the negative 2. So the negative 2 stays, and the u to the negative 3 drops to the bottom and becomes positive. Do you see? So this d over ds, we'd have to rewrite it again. This equals d over ds. So the derivative with respect to s being the variable, that's why they have an s down here now, for s to the negative 5, and then that equals, and when I find the derivative of that, I don't write d over ds anymore, right? D over ds is like writing the word the derivative of this, okay? The derivative of this. So the derivative of this equals, and then I just write the derivative, okay? So the negative 5 drops in front and joins the 4, I get negative 20. S to the negative 6 is a good answer, or negative 20 over s to the 6. Okay, higher order derivatives. If you're given a power rule question, higher order derivatives are quick because you do power rule and then you do another power rule and you do another power rule and keep going for life. So this one wants us to determine the second, third, and fourth derivatives of that. So if I have y equals 2x to the 3 and I do power rule to get it, the next derivative, I can do power rule to get every derivative, so it's quite quick. So y prime would be what? 6x squared. The third would, or the second would be y double prime, which is 12x. Then y triple prime would be 12, and then they stop doing the slashes and they write the 4. Y to the 4 is 0, so it's gone. So every time you take the derivative of a polynomial, it drops a degree, correct? So this one we started with a degree 3, then it went to degree 2, then it went to degree 1, then it went to degree nothing, so it would be a constant function, and then it went to, it's gone. Okay, I want you guys to try and find the first derivative of this one. Remembering to take out a GCF, then try the second derivative. So the only way you can find the second derivative of this one is taking that e to the x out and then doing the second derivative. Because then you'll have another e to the x. Try. F prime is 2x, g prime is e to the x. Please be quiet. So y prime would be g, which is e to the x, f prime, which is 2x, plus f, which is 1 plus x squared, times g prime, which is e to the x. Both of these two terms have a what in them? E to the x. So our first step is to fill in gf prime plus fg prime. Then if we have a numerical base to a variable exponent like e to the x, our next step is to take a GCF of that out, because our first step when we do those derivatives is to rewrite it. So it will exist in both of these every single time. So we have an e to the x and an e to the x, right? Even e to the negative x, we'll have an e to the negative x and an e to the negative x in both of them, because our first step of the derivative of a numerical base to a variable exponent is to rewrite it. So it will exist in both every single time. So y prime equals e to the x, and then we're left with 2x plus 1 plus x squared. Derivative 1 done, right? Derivative 2 is to take the derivative of that. So y double prime. So this is my new f, this is my new g. My f prime is e to the x, and my g prime is the derivative of 2x is 2, the derivative of 1 is 0, derivative of x squared is 2x. So y double prime is g f prime plus f g prime. What's our second step now? Take out an e to the x, right? Because it's in both terms, here and here. So y double prime equals e to the x, and then we're left with 2x plus 1 plus x squared, and then from the second term plus 2 plus 2x. And then before we move on, we're going to collect like terms. We agree? So y double prime equals e to the x times x squared plus 4x plus 3. And then it wants the third derivative. So we just, once again, fg, right? So y double prime equals e to the x, x squared plus 4x plus 3. So this is our f, this is our g. F prime is e to the x, g prime is 2x plus 4. So y triple prime equals g times f prime plus f times g prime. Factor will always give me two terms. Of those two terms, I can take an e to the x out. And then I'm left with x squared plus 4x plus 3 plus 2x plus 4. And then I collect like terms. X squared plus 6x plus 7, which I cannot factor. So I'm going to give you the next 15 before we go to this acceleration question, which we'll talk about, to work on all the ones I boxed.